For more information, please visit SGMAK Associates website.
In this module, I'm going to discuss the most important concept for this course, which is the time value of money. So basic idea is if you have two cash flows separated in time, you can't add them or subtract them without discounting at appropriate interest rate. For example, if you receive $1,000 today and $1,000 end of month one from your friend, it is incorrect to state that you have received a total of $2,000 by end of month one. In this case, there are two separate cash flows, each of $1,000 and separated by a month. We cannot add them without proper discounting. Approach. If the $1,000 received now is invested in a fund and that generates 1% interest every month or 12% nominal annual interest rate, then you'll be earning a $10 interest on $1,000 at the end of month one. So that will grow into a future value of $1,010. So the correct statement is that you'll have a total of $2,010 at the end of month. Two cash flows separated in time cannot be added or subtracted without proper discounting. The cash flow received earlier has earning power, is expected to earn interest and grow as you move it into the future. For example, the present value of a fund grows into a higher future value due to time value of money, since earned interest is added to the fund. The interest rate, 1% per month, that we used in this example, we also known as the discount rate. The future value of $1,000 received now grows into $1,010 after 1 month because we add the interest. We can now add $1,000 received end of month one to this $1,010 to have the total amount received was as $2,010. Again, the key principle is we must bring all the cash flows at the same point in time through proper discounting before you can add them, subtract them algebraically. Moving on, for example, if you deposit $1,000 in a savings account that gives 1% interest per month and you withdraw $875 from the account at the end of month one, then what's the remaining balance? The remaining balance is the future value of the $1,000 end of 1 month is $1,010. Out of that you take out $875, but they are at the same point in time, so you can subtract because you're taking it out from the fund, leaving you with $135. Again, $1,010 is the future value of the initial investment after 1 month, and withdrawal carries a negative sign compared to a positive sign for deposit in the account. Now we subtract $875 withdrawn from $1,010 because both are at the same point in time. Let us review another example. You have borrowed money from a bank to finance purchase of a new car for $30,000. You have agreed with the bank to repay the loan in 36 equal monthly installments. The bank charges 0.5% interest per month on unpaid loan amount. You can compute your monthly payment from using capital recovery factor. We'll discuss it later. And your monthly payment will come out to be $912. So $912 payment, 36 payment end of each month will repay the loan of $30,000 borrowed at a 0.5% rate per month. Now you have just paid the 12th installment. You want to find out what is the remaining balance of the loan after you have just paid the 12th installment. Now you may be tempted to estimate the remaining balance as money borrowed 30,000 minus total amount paid 12 times 912, $19,056. But this is incorrect because the 912 payments, 12 payments there, cash flows at different point in time. You just can't simply multiply it by 12. You got to discount it properly. So we make the error by not discounting properly the initial cost as well as the 12 payments. Remember, the decision is being made, or the question relates to how much money, how much loan I have having made the 12th installment. So time has moved from present to the point where you just made the 12th installment. So at that point in time, you got to find out what's the remaining balance. So the way you compute it, you find the future value of the initial cost, the initial money you borrowed at the end of 1 year, the time you made the 12th payment, minus the future value of all the payments you already made at the end of year 1. So both cash flow are brought at the same point in time, and then we do the algebraic manipulation as needed. So the correct remaining balance is $31,860, which is the future value of the initial $30,000 you borrowed at the end of 1 year, minus $11,250.43. To show this computation better, this amount represents the future value of 12 payments that you make end of each month for 12 months. And that gives you a remaining balance of $20,609.57, which is a little different, as you can see, you got if you didn't discount it. The cash flows are discounted with the appropriate discount rate and brought to the desired point in time before you can manipulate them algebraically, add or subtract based on the need of the problem. Moving on. So to restate the principle, we typically discount cash flows taking place at different points in time to bring them either to the present or to the appropriate point in time in future. In this example, the future values are calculated at the end of year 1, since we are interested to estimate the remaining balance at the end of year 1. That's why you move it from present to the future. In some problem, the decision you got to make at the present time, so everything has to be discounted and brought to the present value. For example, we can estimate the net present value of a project of finite life. This is the concept of net present value, which I'll discuss later. We can find the net present value of a project by bringing all future cash inflow to the present. So you get the present value of all future benefits. Then you subtract all the cash outflow, all the cost in the project. If you subtract all present value of all future benefits and subtract the present value of all cost from the project, then you get the net present value of the project. So we'll compute some problems later on, but the key principle is cash flows separated in time cannot be added or subtracted unless they are brought to that same point in time through proper discounting. That is the cardinal principle for this part of the material that we'll cover through a number of examples. Okay, so that has to be kept in mind as you go through the remaining material on this engineering economic analysis. Hopefully you will like it.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.